The National Electrical Code, or NEC, mandates minimum ampacity for feeder conductors. For a 120 volts, 25 amps, single-phase circuit, the minimum ampacity of the feeder conductors must be 25 amps. To select the correct wire size, it is crucial to consider ampacity, voltage drop, and insulation rating. Ampacity ensures the wire can handle the maximum current without overheating. Voltage drop must be minimized over the circuit's length, in this case 100 feet. The insulation rating must be suitable for the circuit's voltage and temperature, which are 120 volts and typically 75 degrees Celsius. A 6 American Wire Gauge THHN wire satisfies all these requirements. It has an ampacity of 65 amps, which is sufficient for a 25 amp circuit. It also exhibits low voltage drop and is rated for 90 degrees Celsius, rendering it appropriate for industrial environments. In contrast, a 10 American Wire Gauge wire does not meet the ampacity requirements. Its ampacity is only 30 amps, which is insufficient for safely carrying 25 amps continuously. Even if the load does not always draw 25 amps, it is vital to use a wire size rated for the maximum potential load. Using an undersized wire such as a 10 American Wire Gauge wire can pose a fire hazard. Therefore, adhering to the NEC requirements and installing a 6 American Wire Gauge THHN wire is recommended. Using the appropriate wire gauge ensures safe and code-compliant electrical installations. Remember that electrical codes and safety standards are in place to protect people and property. Always prioritize safety and consult with a qualified electrician if you have any doubts. Overcurrent protection is a key component of any electrical circuit, whether it be in a residential, commercial, or industrial setting. Choosing the correct overcurrent protection device like a circuit breaker is important for protecting your electrical system. The overcurrent protection device is designed to interrupt the flow of electricity during an overcurrent situation. This could be caused by a short circuit, ground fault, or overload. If the overcurrent protection device is not properly sized, it may not be able to adequately protect the electrical system. This can lead to equipment damage, fire, or even personal injury. When selecting an overcurrent protection device, it is important to consider the following factors. Firstly, a voltage and current rating of the circuit. Secondly, the interrupting rating of the device. And thirdly, the type of load being protected. The voltage and current rating of the circuit must match the voltage and current rating of the overcurrent protection device. The interrupting rating of the device must be sufficient to interrupt the maximum fault current that could occur in the circuit. The type of load being protected will also affect the type of overcurrent protection device that should be used. For example, a circuit breaker is typically used to protect circuits that supply power to motors or other inductive loads. A fuse is typically used to protect circuits that supply power to resistive loads such as lights or heaters. In addition to selecting the correct overcurrent protection device, it is also important to install it correctly. The overcurrent protection device should be installed in a location that is readily accessible and protected from damage. The device should also be properly labeled so that it can be easily identified. Regularly inspect your electrical system to ensure that all overcurrent protection devices are in good working condition. If you notice any signs of damage or wear, replace the device immediately. Never attempt to repair an overcurrent protection device yourself. Always consult with a qualified electrician. Electrical safety is paramount. Improper electrical work can lead to serious injury or even death. Only qualified electricians should perform electrical work. If you are not qualified, do not attempt to work on your electrical system. Contact a qualified electrician for assistance. Always turn off the power before working on any electrical circuit. Use a voltage tester to verify that the power is off. Wear appropriate personal protective equipment such as gloves and safety glasses. Never work on electrical circuits in wet conditions. Be aware of your surroundings and avoid contact with energized electrical components. If you are unsure about any aspect of electrical safety, consult with a qualified electrician. Grounding is another critical aspect of electrical safety. A proper grounding system provides a safe path for fault current to flow back to the source, tripping the overcurrent protection device and preventing electrical shock. Ensure that all electrical outlets and equipment are properly grounded. Test your ground fault circuit interrupters, or GFCIs, regularly to ensure they are functioning correctly. GFCIs are designed to protect you from electrical shock by detecting ground faults and interrupting the circuit. Electrical codes and standards are constantly evolving to improve safety. Stay up to date on the latest codes and standards to ensure your electrical system is compliant and safe. Regular electrical inspections can help identify potential hazards and ensure that your electrical system is in good working condition. Schedule regular inspections with a qualified electrician. Education is key to electrical safety. Learn about electrical hazards and how to prevent them. Share your knowledge with others to promote electrical safety in your community. By following these electrical safety tips, you can help protect yourself, your family, and your property from electrical hazards. Remember, electrical safety is everyone's responsibility. Prioritize safety in all your electrical work and activities. If you ever encounter a situation where you are unsure about electrical safety, consult with a qualified electrician. Their expertise can help you resolve the issue safely and effectively. Proper use of electrical tools is also essential for safety. Always use the right tool for the job and follow the manufacturer's instructions. Inspect your electrical tools regularly for damage and replace them if necessary. Never use electrical tools in wet conditions. Use insulated tools when working on or near energized circuits. Keep your work area clean and free of clutter. Avoid distractions when working with electrical tools. If you are tired or not feeling well, do not attempt to use electrical tools. Proper planning is crucial for any electrical project. Before starting a project, carefully plan the work and identify any potential hazards. Gather all the necessary materials and tools. Ensure that you have a clear understanding of the electrical codes and standards that apply to your project. If you are not comfortable performing the work yourself, hire a qualified electrician. Communication is important when working on electrical projects. Inform others in the area that you will be working on electrical circuits. Post warning signs to alert people to potential hazards. If you are working with a team, clearly communicate the plan and assign responsibilities. Coordination is essential for ensuring that the work is performed safely and efficiently. Continuous learning is essential for staying up to date on electrical safety. Attend training courses and workshops to learn about new technologies and techniques. Read industry publications and websites to stay informed about the latest electrical safety news and information. Share your knowledge with others to promote a culture of safety. By continuously learning about electrical safety, you can improve your skills and knowledge and help prevent electrical accidents. The National Electrical Code, or NEC, serves as a comprehensive guideline for safe electrical installations. Familiarizing yourself with its key articles can greatly enhance your understanding of electrical safety principles. Article 210 covers branch circuits, outlining requirements for the number and type of circuits in various occupancies. Article 215 addresses feeders, which supply power from the service equipment to branch circuit panels. Article 220 deals with branch circuit, feeder, and service calculations, providing methods for determining the appropriate sizes of conductors and overcurrent protection devices. Article 230 covers services, encompassing the conductors and equipment that deliver power from the utility to the building. Article 240 focuses on overcurrent protection, specifying the requirements for fuses, circuit breakers, and other protective devices. Article 250 addresses grounding and bonding, outlining the methods for creating a safe path for fault current to flow back to the source. Article 300 covers wiring methods, specifying the requirements for installing conductors in various raceways and enclosures. Article 310 deals with conductors for general wiring, providing ampacity tables and other information for selecting the appropriate conductor size. Article 400 covers flexible cords and cables, specifying the requirements for their use and installation. Article 430 addresses motors, motor circuits, and controllers, outlining the requirements for protecting motors from overloads and short circuits. Understanding these key articles of the NEC can significantly improve your ability to perform safe and compliant electrical installations. Remember to consult the latest edition of the NEC for the most up-to-date information.